Okay, I'm going to walk through an example of how to do one of the kinematics problems. So I've got this page of the notes in front of me. This is just as a review. The framework that we're going to use for solving these problems, we're just going to do this for every problem. We're going to draw a line like that, and that, and that. That sort of divides up our space. In this space, we're going to write down what we know. In this space, what we need. We're going to draw a picture here. And then we're going to have our equation or formula right there, and then we're going to derive our answer in this space with units. Okay, so to make that a little more clear, I'm going to do an example of this on this sheet of paper here. So we've got an example problem in the notes. It says a block slides down a ramp with a constant acceleration. It starts with a velocity of 1 meters per second down the ramp. 5 meters down the ramp, the block has a velocity of 3 meters per second. What was the acceleration of the block? Okay. We talked a little bit about drawing axes on things and why axes can be helpful for translating the real world into math. We'll get to see a little bit about that here. So I'm going to start off with a picture. So I've got a ramp. I've got a block on that ramp. Okay, it says it starts with a velocity of 1 meters per second down the ramp, so I'll just draw that, 1 meters per second. And it ends up 5 meters down the ramp, so it's starting here and it's going to end there. So let me make up a coordinate system. I'll say that this is my axis here, and we'll say that this is position 0. So we're going to say the block starts at 0 and it's going to end up at 5 meters. Okay, so it's starting off at 1 meter per second. It's going down the ramp. After 5 meters, it's going at 3 meters per second. So that's my picture. Now I'm going to write down what I need, like what I'm trying to find for this problem, and then what I already know. So it's asking what is the acceleration of the block. So what I'm looking for is A. I'm looking for acceleration. Now I'm going to write down what I know already. So this problem says it starts with a velocity of 1 meter per second. So a starting velocity, that's our initial velocity. Initial just means what's the velocity at the start of the problem. So I'll write down VI is equal to 1 meter per second. Okay. It says at the end, the block has a velocity of 3 meters per second, so that would be VF equals 3. It says that it moves 5 meters down the ramp, so that's sort of our change in position. So I could call this X initial and this final, X final, and then I know delta X from that, so I can just write those down. So X initial, using my coordinate system that I made, is 0. I'll put meters per second here. So 0 meters, X final equals 5 meters. That means I can find delta X. Our rule for delta X is just X final minus initial, so I'll do 5 minus 0, so that equals 5 meters. Then what else do I know? Let's see. So I think those are all the things I know. So then once I've written down what I know and what I'm looking for and drawn a picture, the next step is to choose one of these formulas that connects what I know to what I don't know. So I need a formula that includes this variable and some combination of these variables and doesn't include things that I don't have in this column here. When I look at the first one, I see I don't have a t here, so I can't use the first one. Same is the case for the second one and the third one. So I'm not going to use the first 3 formulas for it, so I'll use the fourth one. So this step here is just looking at our formulas, seeing which one has all of its variables in this column. And when I look at that, the fourth one does, since we've got VF, VI, we've got A, and delta X. So I'll write that one down. So I get VF squared is equal to VI squared plus 2A delta X. All right. And then this is where you could derive a formula. You can either do it by rearranging the letters right now. So, subtracting, we're looking for A, so we could subtract VI squared from both sides and then divide by something to get A all by itself. The other way we can do it is by plugging in numbers. It seems like people are more comfortable with the numbers approach, so I'll do that here. So now I'm going to rewrite this equation, but instead of each letter, I'm going to write out what it equals. So VF is equal to 3, so I'm going to say 3 squared is equal to VI squared, so that'd be 1 squared plus 2. I don't know A, so I'll leave that as A, and then delta X is 5 meters. Okay. Good. So then I'm trying to get A by itself, and I'm just going to follow the order of operations. Or I guess I'm trying to isolate A, so I'm going to use the algebra moves that I know about that I can use. But to do that, first I'm going to simplify anything that I can. So 3 squared is just 9. 1 squared is 1. So squared means something times itself. 3 times itself is 9. 1 times itself is 1. Plus 2 times A times 5 is the same as just 10 times A. If we multiply something by 2 and then multiply it by 5, it's the same as multiplying it by 10. So this just gives us the problem in a simpler form. Then I'm trying to get A by itself. I've got a 1, and I've got a 10 times A, so I'll get rid of the 1. By subtracting it from both sides, I get 8 is equal to 10A. And then getting just A by itself, I'll divide by 10, because I've got it multiplied by 10. So to undo multiplication, I'm dividing. And I get the answer of 8 over 10 is equal to A. When I plug that into a calculator, I get 0.8. And then my units for acceleration are meters per second squared. So that's our final answer.